Section 4.3, example 4 says, what is the solution of the system? Use elimination. For equation 1, we have 3x plus 2y equals 1, and equation 2 is 4x plus 3y equals negative 2. Up at the top, I have the same reminder as before. First, we want to check the coefficients of our variables. For x, we have 3 and 4. It's not easy to make 3 or 4 match by just multiplying one of those two numbers. For y, we have 2 and 3. The same is true. We can't multiply 2 by anything to get 3, and we can't multiply 3 by anything to get 2 using just whole numbers. So this problem requires us to multiply both equations in order to get matching coefficients with opposite signs. It doesn't matter if you want to make the x values match or the y values match. You can choose either one. I chose to make the x values match. In order to do this, we just need to pick a number that both 3 and 4 go into. The easiest way to do this is to just use the values 3 and 4 and multiply each equation by the opposite coefficient. So to make the coefficients of x match, we can multiply 3x by 4 and 4x by 3. Sometimes there's a smaller number you can use, but this method will always work. So if I multiply equation 1 by 4, we get 4 times 3x equals 12x, 4 times 2y equals 8y, and 4 times 1 equals 4. When I multiply equation 2 by 3, I actually want to use a negative 3 so that I get a minus sign on one of my coefficients. So negative 3 times 4x gives us negative 12x, negative 3 times 3y gives us negative 9y, and negative 3 times negative 2 gives us positive 6. Now we can use our new equations to move to step 2. We'll add straight down. So equation 1 is now 12x plus 8y equals 4. Equation 2 is now negative 12x minus 9y equals 6. And if we add straight down, we have 12x minus 12x is a zero pair. 8y minus 9y gives us negative y, or you could put negative 1y. 4 plus 6 gives us 10. This is very close to what we want, but we want positive y instead of negative y. So we need to get rid of this negative symbol. To get rid of a negative symbol, you can multiply or divide both sides by negative 1. Negative 1 divided by negative 1 will become 1, and we're left with just 1y or y. 10 divided by negative 1 gives us negative 10. Now we can use the value of negative 10 for y in one of our previous equations to solve for x. I chose to use the original equation 1, but you can use the original equation 2 or either of our adjusted equations for equation 1 or 2. If we use the original equation 1, we have 3x plus 2y equals 1, and I'm going to plug in negative 10 instead of y. So 3x plus 2 times negative 10 should also equal 1. 2 times negative 10 is negative 20. So we have 3x minus 20 equals 1. Our goal is to get x by itself, so we can undo the minus 20 by adding 20 to both sides. Negative 20 plus 20 is a zero pair. 1 plus 20 is 21. If we bring down our 3x, we get 3x equals 21. Now we just need to undo the multiplication by 3, and we can do this by dividing both sides by 3. 3 divided by 3 gives us 1, so we're left with 1x or x. 21 divided by 3 gives us 7, so we have x equals 7. Therefore, our final answer is the coordinate point 7, negative 10. The work for this problem is written out on the next few slides. And now I would like you to try number 7 on page 250. Solve each system using elimination. 6x minus 3y equals 15, and 7x plus 4y equals 10.